So on this one, so the 18, so yeah, let me just, that's a good question. So the 18, I just took the 18 over here and I broke down the 18. He's a 2 times 3 squared. And then I broke down the 60. He's 2 squared times 3 times 5. So then let me go back to how I built this here, because that's really the crucial piece of the puzzle. So they told me that 18 goes in and 60 goes in. So 18 is 2 times 3 squared. 60 is 2 squared times 3 times. I just broke them down, you know, with the prime breakdown. They told me that up here they said n is divisible by 18 and by 60. That means since 18 and 60 divide evenly into n must contain, what must n contain? Well, he must have the whole 18 in it, because 18 goes in, so he must have a single 2 and 2 3s, right? Because the whole 18 goes in. And then, because the whole 60 goes in, we've got to expand and make more room so the whole 60 will go in, which means we got to have 2 2s, don't we? So I've got to change this to be second power, and then we got to have room for the 3, but we've already got that. In fact, we got more than that. We got 3 squared, and then we got to have room for the 5, so we got to tack on a 5 at the back. So there we go. There's what the n must contain. 2 squared times 3 squared times 5. He must have that much room, because that, again, that allows 2 times 3 squared to fit in, right? 1, 2, and 2 3s, and then all this to fit in, which is 2 2s. So I had to expand the number of 2s and throw on a 5 at the back. So this is got room for the 18 and the 60 now. And then I break down the 20. They're asking, does the 24 go in? I broke down the 24, prime factor it, 2 to the 3rd power times 3. So does that fit in here? That's really the question. Does 2 to the 3rd times 3 fit in? No, we've only got room for 2 2s. We don't have room for 3 2s. So the answer is false. There's not room for that. How about we do one more? I know this is tricky. How about we do one more real quick, and maybe that'll be helpful. How about 6 and 9 both divide into n? So does 54 divide into n? True or false, or yes or no? All right, so how are we going to do it? We got to take the 6 and we got to break it down, right? It's all about prime building blocks, 2 times 3. And then we got to grab the 9, break it down, 3 times 3. So 9 is 3 squared. And now we've got to write n must contain. What must n contain? Well, he's got to contain everything the 6 has, right? Because 6 goes in there. So he's got to have room for the whole 6. So he's got to have a 2 and a 3. Got to have room for a 2 and a 3. And then the 9 also, right? 6 and 9 both divide evenly into n. So he's got to have actually room for 3 squared. So I got to add a 2 power there, don't I? Do you see how I expand it? So I take the first one verbatim, 2 and 3. And then when I come to the second one, I add whatever I need to add so that there's room there. So I had to make it 3 squared, right? So now there's room for the entire, n has room, a single 2 and 2 3s. That gives room for the 6 to fit in, 2 and a 3, and room for the 9 to fit in, 3 squared. Individually, one at a time, either one can fit in. Now, here comes the big question. Does 54, so what's in a 54? Well, we break it down, 6 times 9, 2 times 3, 3 times 3. So 54 is 2 times 3 cubed, right? We don't need the 6 and the 9, just they broke apart. 2 times 3 cubed. Does this fit in? Fit into n? So is there room for a single 2 and 3 threes in this in here? And what's the answer?
False.
Yeah, it's a false. It's a no, huh? Yeah, because this has 3 threes is too much. There's only room for 3 squared in there, right? That making sense? Questions I can answer?
How come it was 2 times 3 squared and not 2 times 3 cubed? Because isn't there 3 threes like in total with the 6 and the 9?
Yeah, right. Very good question. Yeah, it's what it is that we're not adding them up total. Yeah, that's a great question because yeah, you might think, well, there's 1 3 here and 2 3s there. Shouldn't we have 3 3s there? Great question. We're not adding them up. We're just having room. Does that make sense? So that'd be kind of like room. I should say room for them to fit in one at a time, not all at the same time. So does that make sense? So I'm just saying originally I need a 2 and a 3, 2 and a 3, just for the 6. And then when I come to the 9, I don't add a whole nother 3 squared. I don't just tack on the whole thing. I just expand what's already there so that it has room for that, which means I just have to make that 3 squared. And now the 9 will go in right there. So the deal is that we're making each one fit in individually, one at a time, not both at the same time. That's the key difference. We're not just throwing all this stuff and all this stuff together at once. We're doing them one at a time. So I take the 2 and the 3 first, just the 6, and then I come to the 9 and I've got to make that a squared, because that gives room for just the 9 to fit in. Another way, you know what we're really doing, if this is helpful? We're doing the LCM. It's really the LCM. That's what it is. Why? What do I mean LCM? It's the highest of each power. You see that that's what we actually just did there? We just did the highest, right? If I came down here and I wrote the 6 as 2 times 3, the 9 as 3 squared, right? And I put a line and a line and a line. Remember our line them up thing from the GCF? And the LCM and the GCF, and I said, what's the LCM? Remember the LCM from our earlier homework, you take the highest power for each prime. That's what we're doing. So I take the highest power on the 2 is just 1. Highest power in the 3 is 3 squared. So you see, I don't take 3 cubed. I don't just add them up. I take the highest power. So there it is. There's the LCM. That's what you're actually doing, because that's what it means to have room. That's what it means to have just enough room for the 6 to fit in and the 9 to fit in. You take the highest of each power, so you've got room for each one alone. 6 alone can go in, 9 alone can go in.